so it gives a good chance to introduce why we set this question. So we have a very young team, which is due to the investment we make in youth development, but also trusting in the young players. So we have a very stable game model that the players know, and a very defined game model. Part of that is includes possession, a lot of possession and transition. And then because we are one of two clubs that have an artificial pitch in Denmark, we can play quicker football, especially in the winter, we can play quicker football. So we find that a lot of teams defend against us in a low block, which is the reason why this was like a key topic that we wanted for Vignesh to look into. Our game model, as I said, is very defined, but we have a kind of gut instinct, or the coaches have a gut instinct of the success rates, but we don't actually have hard evidence of the success or the efficiency of different strategies that we use to break a low block. But the coaching team do think that the use of data to allow us to test and monitor our game model is really important. So we wanted to identify the low blocks, but also to see which strategies were effective, which was the kind of question that we put to Vignesh. So over to him.
So just kicking on from what Joe said, we'll just look at key points that we're going to go through in this presentation, right? So we want to define what is the low block. So how low is low, right? And does the data really show this? Stuff like, ideally, even if it does, what defines a team in a low block scenario? Then we'll identify a method that basically we found works and is intuitive and that works in a high performance environment. And the second bit of the question is, how can this low block be broken, right? And just around strategies employed that directly link to what Joe said. That's the game model that is defined by the club. And based on identifying strategies, prior to that, we have to define bespoke metrics that are very useful, basically translate a few strategies that the coaches mentioned, and then how do we translate this to data, and how does it work within the given situation. And ultimately, the most important question, right, is how does this solution directly link to performance analysis? I think for the larger part of the audience here, we'd want to know how much easy does your workflow get. So before we get started, I want to just go over the benefits of working with the football club. We had to gain expert knowledge on most situations because all of this is an iterative process, and well, most analysts might know, and most analysts might have experienced when they go back to coaches and show, well, this is what it is, this is what it's thrown up, and they say it's rubbish, right? But this is what we feel is a benefit of working with the football club. The specific use case being here, we have the use case, as Joe mentioned, why does a club actually need to identify these low block scenarios, right? And it's easier to narrow down the focus of our investigation because we are focusing on just one particular scenario, and which is beneficial to our club, bearing in mind the strategies of our club. But for the larger audience, well, this will actually benefit the larger audience because these are situations that a club maybe bottom of the league is trying to fight relegation, might help, and also the top of the league, right? So the challenge is basically, and the question posed was, how do we define low blocks, and eventually how do we go on and break it? So we've broken this problem into four segments. The first segment was we thought to optimally use data, and we identified tracking data as what we think is best, helps us best to define low block scenarios. Second, we identify where FC Nordsjælland has broken a low block, right? Third, we've referred the playbook, like every club has. We refer to the playbook to label strategies that have been used, and also expert opinion, right? And eventually, we want to know, just define a way of measuring these strategies and how effective are these strategies, right? So, going over the approach, right, and there might be a few pessimists in the room, but we've used a rules-based approach that basically uses a temporal geometry triggers to define and filter out strategies and scenarios, right? And we did consider the positives and negatives, all of it. One, immediately, I think all analysts will agree that the benefit of working in the club, or benefit of working with, you can always go back and lean on expert knowledge, which is what we did. We reached out to multiple practitioners to identify if this is works within the performance environment. And that's what we need, right? We require buy-in into our ideas to bring the two sides of the coin, really, of bringing data and using football knowledge to basically identify the scenarios. The fact that the positives of using a rules-based approach is we can always go back and say, see, these are the rules that you defined, and if these are the rules you define and it throws up false positives, then we can clearly state that maybe it's not right. So it is club specific, so we have defined the rules based on FC Nordsjælland's way of defining rules, right? And it's intuitive, and there's no scary black box neural network or stuff that we can't explain. It's fairly intuitive, and you'll see. And negatives, obviously, it's less tech savvy, tech sexy, and it is an iterative process where after every iteration we go back and say, and then they say, maybe this is not right, and then we add in a few more rules, common rules, and not basically subsetting a larger part of the data, because we want to see stuff that basically goes beyond rules, right? We also want to see a few things that, giving a basic set of rules, we want to see everything, all kinds of situations based on the rules. So we had a sort of set of rules to define a low block. The first rule we used was basically identify centroids of both teams, right? We use centroids of both teams, but predominantly the defensive team, that is our opposition. And a low block was defined by the club, and that was the zone that you see on the pitch. And if the centroid of the defensive team falls within that zone, then that's one of the rules of a low block. Right, so intuitively, all 4 defenders, not more than 3 defenders, have to be in the box at any point t, at any time t, sorry. And if more than three defenders, that's 4 defensive players, are in the box, they progress or regress into a deeper low block, right, from a low block. But that is not the focus of what we have today, because going from a low block and into a deep low block is natural, and it's not something that we could really do something about. And also, if there are more than 2 players in the attacking half, wherein of the opposition, then definitely can't be in a low block. And I believe you would agree with me, because there would be a lot of space in between the lines, right, if there are 3 players in the opposition half. So, and the last rule is we subset the data based on the set pieces that we have. We use a time lag of 3 seconds after free kicks, so that we don't get those free kicks in, because predominantly a larger part of free kicks are low block based, right? And also no attacking corner within the last 10 seconds. So that basically subsets all these set pieces that we don't want to see. We want to see low blocks that are in open play. So how does it work? So if you see the green dot right in the middle, that's the defensive centroid of the opposition, and you see the purple dot, that's our centroid, which we don't really care about. We care about the green dot, and you see the green dot is in the low block, so that is defined, and this basically, we can say that this is a low block, and that's just basically based on the centroid of the defensive team, right? It's a bit slow. but this predominantly, these are the situations that we're looking for, and we have based it on time segments. So we have summarized it based on time segments from where the frame. So we've gone by 0.5 seconds, right, for across time sequences, and for every 0.5 seconds, where are the players on the pitch, and where is the centroid? And if it falls within that low block zone, well, they are in a low block. So we see the start and the end frame, and we summarize it as sequences of time. So we did reach out to many practitioners based on our approach. We wanted to receive buy-in to see if this really works. So we reached out to Devin, who was here last year or the year before, just giving his talk. And so this is what he basically had to say. He also thinks geometrically temporal models like this one make sense, and it works. So intuitively, we know that the way we define breaking a low block is basically if there's a ball played in behind and a player is in possession of the ball, that is basically we breaking a low block, right? And we can, how it works is we can break a low block more than once in a given sequence, right? So just want to play that again. So you see the ball, and then, yeah, and there's a cutting pass. So how it works is we use the average position of the last two defenders. That's what we define as the last line of defense from the goal line. And if there's a ball played in behind, and if we are in possession of the ball, that's us breaking a low block, right? So, and we went back to the coaches and they said, listen, what do you think are strategies we use during these low block scenarios, right? And this is one of the strategies they came up with. And all we had to do is, once we have the strategy, we define KPIs and then merge them together. And how we define these KPIs is basically translate the same strategy to data. So one of the strategies was wide overloads, right? And there's something that many clubs look at, especially in low block situations. So here we define overloads as either a 3v2 or a 3v3 situation, or a 4v4 or a 4v3 situation. So basically, if we are numerically, we have a numerical advantage of just one, we still overloads, or if we are equal in numbers, we're still having, that's still an overload. That's how we defined it, right? And the reasoning behind it is just varying pace of the tempo of the game, and then try to get runs in behind the half space, which we'll go into later. Just to explain how we actually came up with runs down the half space, is first we defined forward runs. What would a forward run look like? And we'll just get down to that a little later on because we'll be discussing how we define forward runs. So it's basically wide overloads. I'd like to show how it works. So you can see a 3v3 situation down on the right wing. And similar. And we basically try to see the wide overloads in both these zones. And these zones were defined by the club again, okay? Because in many clubs, there are a lot of strategies where we feel like we can gain advantage and progress the ball further in certain areas of the pitch, right? That's what this basically states. So we believe that in both sides of the pitch, this is where we feel we want to get overloads, right? So then we define a wide pocket to a half space run, right? So wide pocket is basically out and wide, and then do we see, as we slow the tempo down, we want to see players run into the half space, and if they're running into half space, does it lead to a breakthrough, right? So basically, that's self-explanatory really, and just to see if we can find that gap to get that run in. So we see, and that's that ball through, right, to find a player that goes in and almost breaks that line. So fast switches is fairly straightforward, where we get the ball and then we define the speed of the ball. And then when it moves out wide, we just define it as into wide areas, which is defined already. And when it moves onto wide areas, that's a quick switch, right? That's basically a quick switch. So the importance of high speed, of pace, playing into wide areas. So that's what the club feels that, you know, in situations like this when there is a low block and we feel like we want to quickly switch it out wide, it makes sense when we can't go down one side of the wing, right? And decisive off-the-ball runs. So when you try to define forward runs, right, we basically first define forward runs. What would it look like? So we used speed segments from the tracking data, and we used the top 3 speed segments. We went back to the coaches, we showed them, and we had a list of samples where we said, and the coach said, you know, I want to see if there's a forward run being made, because that's what they say, right? You can see and tell if there's a forward run being made. So we use speed segments to track players from the start of the sequence and towards the end of the sequence, and when they go from jogging and walking all the way up to high-speed sprinting or high-speed running is when they made a forward run. And forward running behind would be basically if he receives the ball behind the last line of defense, right? And half-space run. Half-space run was we used. We kind of looked at 2 approaches: either finding the median or the mean or the average within that sequence. If a player's median location within that sequence lies in the half space, then he's made a half space run. If he's not in the half space, it's just when the sequence started. So this is how it works. This is the run in behind, and then set ball through. It's an aerial ball and tracking data. Looks like that. So basically, what we're trying to find here is these assertive runs that are being played and triggers. We define triggers when players receive it in pockets, right? And we went back to the coaches and they said that this is the major strategy they try to employ during low block scenarios. They feel that players getting into those central pockets of space within that radius you see, that's defined in tracking data as well as a risk radius, and we define it as any player that is in a low risk radius. That's the extent we have, right? So he could receive it in a high risk radius where a player is closer to him, and he could receive it in a low risk radius where a player is a little away from him. The risk radius is about 3.5 yards or meters. So if you receive in central pockets, high importance to receive in central pockets and the ability to play forwards. So this is one strategy where we just receive the ball in central pockets. It could lead to a shot, it could lead to a breakthrough, whatever. So he's received it in a central pocket. It's an aerial ball. He's received it right there, and he gets a shot away. So we need to analyze these frequencies, right? So we look at the average number of times, basically a frequentist approach. Average number of times we use either of these strategies. We found the probability of a breakthrough from using each of these strategies. We feel that this is one way of measuring effectiveness of each strategy. We found the probability of getting a shot away given a breakthrough. This was used. We combined event data to tracking data to see if a shot given away, and the XG if we have broken through and got a shot away, and also the XG of the overall strategy attempt. Right. What's interesting here is reception in central pockets was our strategy, our main strategy. That the coaches said that we should receive in central pockets and then play out balls, and if that leads to a breakthrough or not. We were out. This is like a benchmarking tool, right, to see how many times we actually use the strategy. And a decisive off-the-ball runs is intuitive because, like, if we want to break the line, and if, especially if we are playing a team that basically sits deep into its own half, what we want to do is make runs in behind to get in behind, right? It's interesting because our wide pocket to half space run, even though we average more wide pocket half space runs, the consistency of getting a shot away, given a breakthrough, was much lesser or more inconsistent to having a strategy such as wide overloads, which was probably consistent throughout getting the number of wide overloads, right? What it means that we ideally have to have more number of shots, given the number of times we actually average this strategy per sequence. Finally, the wide pocket half space run, we identified that this had the highest XG of strategy attempt in terms of other strategies. It's interesting because even though we are receiving in central pockets, we feel that we are actually having more shots and getting away a higher XG using that strategy. And finally, in terms of reception, we are averaging more receptions in central pockets than, the second highest, and then are we actually, what does the XG look like for that? So comparatively, it ranks fourth. So again, this is just a benchmarking tool, right? And this is basically a framework for something that you could build on. And we thought this was a preliminary stage that helps analysts and gives us an idea of using a frequentist approach to analyzing how to break a low block. So we did some testing, and so everything was done on Python, and it's easy, it's free. What we did was we used the code through tracking data. I think Dan previously, earlier in the day, mentioned how hard tracking data is, but our code runs in 4 minutes because we are looking at specific scenarios, right? And we could directly export this to XML and import it through sports code using time segments, and we have proxied strategies and low block scenarios, so it's something that we could look at directly. How are we doing the strategy? What does it look like, right? And we could always go back and change something if, in terms of strategies or low blocks, if it doesn't look right, because you're always going to get false positives. But the rules that we defined were basic and helped us identify scenarios. So interestingly, we could actually get these video under 5 minutes. Tracking data we have, as Joe mentioned, takes about 24 to 48 hours after the game, but I'm not sure about in Premier League. Premier League teams, if you get it live, they can actually do this in real time, and it would take less than 5 minutes if given we finished one half, right, and then we can analyze that at halftime. Future research, we did go through a kernel density estimator when we were trying to analyze low block scenarios, but it wasn't very intuitive. It wasn't giving us values, and we thought centroids were better to use. Towards the end, we also tried to use a neural network to analyze a sensitivity analysis that basically helps us tell what are the influential variables in all of them that actually change the probability of the outcome, right? And these are just basic rules, and this is just a basic framework, something that we could go work upon. We also define combinations that are player-specific, but just because we were summarizing this at a team level, we didn't include that. But we could include combinations, and we could see our vision players who are part of the highest number of combinations through tracking data as well. Thank you.